Yes.
Get him! I see a Zoe and Harrison and a James. Allie's son.
You are?
A
Yep. Woke up.
Leah. Emma, Jacob, Alexis, yes, Emily, Eva, Bailey, Katie. Was here.
How long ago was that? What? The dynamite and all that, and then Hammerman's game.
Brooke.
7:08. No, not 8. No, yeah, that's right. No, 6. Come on.
That's entirely too much flapping those lips if we're doing our work like we're supposed to. Remember, we want these to be fairly quick. 10 minutes tops every day. Open notes, open books, open homework, open whatever. Close mouths. Uh-oh. Okay. Yeah, I overheard him saying something about...
He punched the mustard packet and it got all over my window.
That's a choice. Still a little discombobulated there, Jaden?
Yeah.
Tell you what, you were in here for like a solid 2 minutes last block.
Yeah. Basically.
We'll just say that it counts. It happens. That's what they're there for. Get them. Come on.
What? I know what this is.
No, you're not. And if you say that again, we're going to throw hands after school.
Oh, that's true.
Do we have to go back to this again? Shut it. I want to know what you know now, what your neighbor knows. Also, make sure you are labeling these. Tomorrow you're going to do your in-class review and quiz. You're going to turn all of this in, your notebook that has your notes, your daily quizzes, your assignments. You turn all of that in tomorrow. No, tomorrow. 5 days, then quiz. 5 days, then quiz.
Oh, yeah.
You might get integers, you might get rationals, might be pretty, might have gotten run over with the Mack ugly truck. I don't know. Just run with the numbers. Fractions are numbers too. And that is exactly what I don't want. Anyone still rolling? A little bit? Okay. So with that extra 30, 60 seconds, again, tomorrow, it's not a big deal. We do 5 days, review and quiz. 5 days, review and quiz. All semester long. You can do it, what, 12, 15 times? Okay, it's not a big deal. On that day, open notes, open book, open everything. I don't care. We're going to review a couple of problems. You're going to do a few problems. You throw the quiz in the basket. You put your notebook and your packet of notes up on the counter. This will hopefully all be gone. I check through it real quick, probably in another class or after school. If you want to come back at the end of school and grab it because it's so important to you to have, cool. If you're one of those kids that's got like multiple subjects in a notebook or something, make sure I know so that I do those ones first, or I check through those first. Otherwise, you're not going to have homework anyway, so just leave it here and pick it up on Friday at the beginning class. Okay? Like, it's really supposed to be low stress. Every couple of days, I'm going to turn my stuff in and take a quick quiz. That's it. That's the whole class. Okay? Round one. Before I go trying to isolate this absolute value and, it's in two different spots, I need to clean this up first. So stage one is going to be, I'm going to subtract 2. I'm going to get rid of that 1/3. Now dividing by 1/3, quite easy I hear, almost pi-like. Because flip the second multiply, right? How many of you got caught in that trap of seeing compatible numbers and wrote 4? So, go off to the light side here. We have 4x minus 1 is 36. Divide and get x is 37/4. Or if you're going to be that kid, 9.25. Over on the dark side, we have 4x minus 1 is negative 36. So x is a negative 35/4, or a negative 8.75. And to graph it, nice and easy, you just got a number line that has those two on it. That's it. Option 2, I don't have to go isolating the radical. We're doing radicals and the other. You don't have to isolate the absolute value because it's already all by its lonesome. Instead, you're just going to light side. 7x plus 3 is less than or equal to 11. So 7x is less than or equal to 8. So x is less than or equal to 8/7. On the dark side, they got cookies. 7x plus 3, negative 11. What do we got to remember? Flip that inequality because you're on opposite land. So 7x is less than or equal to negative 14. X is, greater than or equal to negative 2. So one of them says x has got to be bigger than negative 2. The other says x has got to be less than or equal to 8/7. So everything in between, it's one of those and sandwiches. It's going to be from negative 2 to 8/7. Close circles. Okay. So, our pointage. Did you split into positive, negative on both problems? Did you put the correct thing on the negative side? Because that's usually where we goof up. Did you get the correct answer for the first one, correct answer for the second one? Are the graphs correct for the answers you had? Okay. So those are the things I'm specifically looking at. Did you split correctly on the negative side? Did you have the answers correct? Were your graphs correct? Okay, there's your 5. Again, if you goof something up at the very beginning, let's say going from yellow to purple on the first one, you said 4x minus 1 absolute value is equal to 4. Very common, oops, brain fart. Did you still from there separate it correctly? Did you still solve those two equations correct? Did you still graph those 2 points correctly? If you did all of that, okay, 1 off, because that was the one thing that you did wrong. Naturally, the more things you do wrong, the more off. Okay. Now, we won't always do it like that either. Sometimes, especially when it's just one larger, more complicated problem. Instead of having points for specific features, you'll see a Likert scale instead. You've all seen them, you probably just haven't heard it called a Likert scale. It's, I got everything correct, perfect, I got the work to back it up, nailed it. I made one little goof. I know exactly where it is. I did everything right, but I just did arithmetic wrong in this spot, or I missed a negative, or something like that. All right, I screwed up. I know where. Like, I know what I'm doing, but I screwed up this thing, and I screwed it up fairly significantly. I screwed up so bad that at least it's only partially recognizable as somewhat the right thing. I attempted the problem. I didn't even attempt the problem. Okay? So, sometimes we'll go Likert scale on it. Not often. Usually we got specific features we're looking for. But if there's ever a question as to, I'm not sure if this is a 3 or a 4 kind of business, then by all means, talk to me. The homework. We had one day where y'all were just blasting me with questions. It was great. And kind of radio silent since then. So before I go even putting the book up here, how'd we do?
Very good.
Was there anything from it that we got to go over? Something was a little sketchy?
26.
Okay. Here, where'd my... There we go. Oop. All right. You all have a physical copy of your book. A reminder. How do I get to my digital book? I'm starting. Blank page. Where is Clever? Okay. All of you have it as an extension on your laptops that is also at the top of our class page as a link directly to it. You go to the thing, you scroll down. You won't let me scroll down because you suck. I'm gonna beat some. Okay. Now what? Savas Easy Bridge. Remember, weird names. Hemorrhoid medication. Come on now. Are you ready to live your life? Talk to your doctor about Savas. Make sure that you are using Realize. They do have different program. And then depending, I don't know, is anyone else using Pearson besides math department right now? Okay. I know a bunch were using McGraw-Hill.
English or Spanish.
Okay. So you might have multiple books off to the side, but I just want to make sure you can get in there. What I usually tell kids is unless you're just a fan of the physical textbook, I just want to go old school and have the book in front of me. If that's your jam, cool. Lug it around with you. 90s, man. If not, I recommend just take the book home, leave it at home. That way, if you're at school and our internet is just toast, we're just going to hang out in here and play games, okay? That's their fault. If you're at home and you can't access your online book because internet craps out, well, now you have your physical book there. Okay? Is it? Oh.
We're like the third person that said that.
Okay, so I guess some people were having problems with it. You got to remember too, we're gonna have just tiny little fluctuations and weird stuff happening between that side of the country is on fire, that side of the country is underwater. Wait, no, that side's underwater. That side doesn't have power or water. So, like, it's going to affect the grid. You might actually see power fluctuations all the way into the center of the continent because of things happening 1,000 miles away. Weird things like that might happen. I don't know if you remember that. Was that last year? There was some real big issues with, or no, this summer or spring, when there was a gigantic heat wave that blasted Texas like a month or two earlier than it normally does, and we were losing power here because theirs was just milliseconds away from collapsing. So leave your book at home just so you always got that as a backup. You said 26? Okay. I can almost hear the dial-up noise from my childhood. God, this is just atrocious. That does show you how quickly things progressed. Y'all, I'm 36. I remember 97-cent gas. I remember going to Blockbuster Video. I remember bag phones. Have you ever seen those? The first mobile phones was literally a bag, like a little duffel bag that you would set in their center console, plug into the cigarette adapter, and you literally picked up a phone that was corded into the bag, and you dial the number, and you get to call someone. Okay? I'm only 36. I remember all this stuff. Now look at it. Look at what you have in your pocket. Okay? It's just bonkers. No, not you. All right. I'm a beat.
What's the board's name again? Frank.
It's Frank. We're gonna yell at Frank. What's friggin' 26? God, I hate this board. This thing's like older than you guys. 6Y. It was what?
22. Less than.
Less than 22. Okay. Stage 1. You want to get the absolute value by itself. Stage 2. You have the light side. Solve it like normal. Add 2. Divide. 20 over 6 reduces to 10/3. But it's not equals. It's less than. What we got to remember is when we come over to the negation of that, it's the opposite of, it's 6y minus 2 greater than negative 18. So you add 2, divide, 16 over 6 reduces to negative 8/3. So I got to be less than this positive number, but greater than this negative number. You turn it into an and sandwich. If you're not sure, sketch it. You say at negative 8/3 that way. At 10/3 that way. Since they cross the wires, it's everything in between them.
Do
Yeah.
we get a brownie point then if the answer, the solution on mine was 2 and 3 seconds? Like on the, yeah, was brownie point something?
Isn't 10 divided by 3?
No, for the other answer.
Isn't 8 divided by 3?
No. Yeah, one of the answer on mine is 3.5, and the answer that we got is
3 1/3, 2 2/3?
yeah.
Mixed numbers are the same as improper fractions.
Well, what I'm saying, the solution on mine is 3.
I don't take responsibility for a book that was published 10 years ago.
Oh, those are the book's answers?
That ain't me.
Oh.
How much time do you think I have?
Never mind then.
No. I just downloaded the PDF and gave you guys a link for it. I don't got that kind of time. No. Very no.
No brownie point for that?
You don't get no brownie points for something I didn't do. We could have just saved like 6 minutes if you had led with that.
I didn't know.
All right. I did tell you like the brownie point thing, right? I don't remember. Oh, Jesus. Okay.
Yeah, like 2 days ago.
So, all right. If you have ever had McCreary or work, they stole that from me. I've been doing the brownie point thing for 13, 14 years now. The idea is I'm a human being. I'm going to screw up. Any math teacher who's ever been in front of you did the thing, and you're like, well, isn't that a 5? And they're like, I'm just seeing if you were paying attention. They are so full of it, and everyone knows it. They're just trying to save face. No, I'm a screw up. I screw up a lot. You know why? I'm friggin' human. Contrary to popular belief. I'm going to goof. If I goof and you catch it before I do, brownie point. After the 25 brownie points, I literally bring in brownie. Y'all, my wife knows how to cook. Okay? Like, literally, it's a tray. It's like the giant baking trays, the whole thing, just brownie. Okay? If we got do we have anyone with food allergies? Gluten kids? Peanuts? I had one kid a few years ago who was allergic to apples. Just randomly, just apples. Anyone? Yes.
Apparently.
I feel bad for the kids who are allergic to chocolate. That's rough. Okay. But yes, if you catch my mathematical error, English is a whole different thing. Catch a mathematical error before I do, pointing out brownie points. All right. We left off with example 4. I know we did this. Did we do this?
Yeah. Wait.
I know we did the top one. I don't remember about this one. Okay.
We were on behalf of problem 6. We did that.
We did this.
No, we didn't. No, we did that. That was the last thing we did.
Okay, so we finished problem 4. We did not do problem 5.
Correct.
Okay, we'll start there then. So,
No, we did problem 3.
these ones. I had said, just look at what it says, absolute value less than 5. That is saying the distance is less than 5 units away from 0. So what's it going to be when I flip that around and now it says greater than or equal to. Now what?
Same thing.
Well, if before the distance was less than or equal to 0, shaded in towards the 0. Now it says the distance is greater than 6. So it's going to go outward from there. The difference between an and inequality and an or, I should not have to talk over 3 separate students. Okay? So, solve it just like before. Did we or didn't we? Okay. We go to the light side and say 2x plus 4 greater than or equal to 6. Bring it all the way down and say x is greater than or equal to 1. And 2x plus 4 is less than or equal to negative 6. Subtract 6. Divide. So if I am to graph this, the other ones ended up as an and sandwich. These ones, the official graph for it is 1 and negative 5 to either side of it. Now, if that's what the graph looks like, my answer, you just jam an or in between those two. Just like when we did compound inequalities the other day. And goes in towards each other, or goes outward from each other. Okay, modern American family. I live at mom and dad's house, or I live at mom or dad's house. Either we live in the same spot, or I take turns at 2 different spots. Okay? And or. Same thing. Okay? A, do exactly what I just did. B is just asking you what is the graph going to look like without actually solving it. Well, as soon as I see absolute value is greater than a number, I know it will be an or graph going 2 separate directions. Don't have to move anything yet. Just roll with it as is. 5x plus 10 greater than 15.
Like that's not.
Subtract, divide, first answer. You got to remember when you head over to the dark side, flip the inequality and negate it. So it's got to be from -5 backwards and from 1 forwards. Both.
This one's saying it is.
Since they went opposite directions, it is or. So if I were to look at this and say, I'm not going to solve it, but I know what the graph looks like, what's the graph going to look like? Just in general. Splitsville, right? Headed other directions. The idea behind this is, I just said that the distance that thing is from 0 is greater than or equal to 2. So thing is at least 2 units away, right? 2 or -2. This says thing minus 3. So I will end up adding 3, 1, 2, 3, to both of them. It's still going to be this graph, still pointing both directions. It's just where it goes changes. Okay? The fun things you get to do on a smartboard instead of on a piece of paper. So, with that, we're going to back up here because we had some extra practice stuff that we never really got to. I'd like you to try with a little more oomph to it. No, I was deciding if I wanted to do all 4 of them. We were going to do 63 and 66 no matter what. Yep, we'll try those 2.
I mean, it's fine if you want to do like 27. Oh my goodness.
Hey, didn't we have this the other day, though? Don't be afraid of the fractions. If you don't like the fractions, multiply to get rid of the friggin' fractions. Right? If you don't like fractions, just multiply so there's not fractions.
Exactly.
We backed up a slide.
Okay, let's get it. Let's get it. Really? No, add 3 over first. Okay. 5 seconds.
So quick. This is how I kind of like explain it in a way.
Okay.
That's like 4 words.
Yeah.
Like I said, like with like the quizzes on the board.
Yeah.
Like,
That's more your jam? Okay.
it's kind of like
All right. Let's try it then.
so. let's
Talk
say-
it through.
So I have to get this over here.
Yep.
So add 3 to this.
Roger that.
So I get 5.
Roger
Then I
that.
have to times flip it to 9.
Yep.
So this would be 45 now.
Roger.
And then from there I have my thing. So I would say 5x minus 3 is that one is greater than
Yep.
equal to. That's I kind of struggle with those two. So now that this, just have to add 3. So now it's 48. But that's the light side version.
Yep.
So I'm gonna branch off here. Take this. then continue going. Add 3, so now I get 5x is greater than or equal to 48. Plug it into the calculator. Actually, I don't really need to.
Just leave it as a fraction. Just make sure you reduce it.
It would just be like 48 fifths.
Yeah.
That's what I could.
Just leave it like that.
48. Or no, 48.
Yep.
And that would be.
Yep. Sign is still the same.
Now this one I have to flip this up to less than.
Yes.
I like this. See, explaining it helps me way better.
Talk it through.
I love it.
I had a student years ago. We were doing the state assessment, like the Smarter Balance. Kid failed it like 3 times in a row, and in that state, you had to pass it to graduate. Having trouble, Minnesota. We're having trouble. Finally, I was like, kid's got ADHD, and he never shuts up. Put him on the computer in my office and let him talk through the whole test instead. He was one of the highest kids that scored in the building. 1,500 students in the high school. Talk it through. Mutter it through. Yeah. Yeah. Yep. Splitsville from those two. You got this. Yep.
Okay, I'm slightly confused. Are we allowed to times this by 3 when it's in absolute value, or is that like a no?
Because like with multiplying we could because it wasn't like, but can we do that with the dividing?
You can, but there's corner cases where you'll run into trouble. I would rather just split now.
Oh, because there's nothing next to that.
Right, because this is a singular term.
Oh, and then we can solve it afterwards.
Yes.
Okay, that makes sense.
Yo.
Did I do this at all right?
Did I do it at all right?
Negative 4.
So we did 9 by the whole works. Okay, right here you actually multiplied by 81. Because, you see how this part is in absolute value? When you did this and this, aren't these two multiplied together?
Yeah.
That means technically this is a single term.
Okay.
If I multiply this by 9, that part's gone. It's just this. And then it's just like parentheses, right? I don't ever distribute past parentheses. If I had 3x minus 2 plus 5, I wouldn't do this, right? Because that plus is there. So
I don't go past there.
if you're going to use 9 to the entire thing, then you need to remember that this is all jammed together without a plus or a minus breaking it up. So it only gets 1 9. That gets a 9. That gets a 9.
So this stays the same.
So it'll stay 5x minus 3 in here. There's the 27.
Okay.
And there's the 18.
Makes more sense. Thank you.
Yep. That's why we usually add the 3 over first, then do that, so we don't run into that exact problem. Okay, looks like most of us got this one down. First, isolate your absolute value. What are we arguing about? I'm betting it's not math, given the sheepish expressions right now. Okay. Isolate the absolute value, then go Splitsville. That's 5x minus 3 is greater than or equal to 45. I missed my or equal to here. Run it all the way to the end zone. Leave it as 48/5. You don't have to go to decimal town. Don't you dare go to mixed numbers. Those are just gross. Just leave it as an improper fraction that's reduced as you can. In fact, that's how all modern calculators are. Okay, I said modern calculators. The TI-83 was what I used in high school. These things have been sitting on Walmart shelves for the last 18 years for 10 bucks. Okay, this will put it in mixed numbers. Sorry. Any modern one, okay, even just basic Casios. These $10 Casios, gotta love them. Those are going to put it as an improper fraction, 48/5. Menu-based Casio graphing calculators are amazing. I wish more people would use them. They're like 40% the price of TIs. But TI owns the education market, so all of our textbooks even talk about these, even though those will do just as much. I hate it. Hate it. I was actually on the trial group for the Prism. Casio Prism is a menu-based full-color graphing calculator. You can get them for 50 bucks. 50 bucks, works great. Does things this one ever will. Never see it in a school because TI owns it. 5x minus 3 less than or equal to negative 45. Negative 42. Just leave them like that. And then it'll be a Splitsville graph on those two numbers. Isolate the absolute value. Isn't this thing is more than 9 units away? So I can split right now. Thing is more than 9, or thing is less than negative 9. Okay? And if you don't like the fraction, multiply to get rid of the fraction. Okay, multiply both sides by 3. Subtract. 32, yeah. And again, Splitsville from the 2. Yes, sir.
What if you multiplied where you have it in the yellow? What if you multiplied by 3 there on both sides?
Okay. Same thing was asked back there. Yes. Technically, technically you can multiply into absolute value just like you can kind of distribute into parentheses. But there are corner cases where it screws things up. In my experience, rather than teach kids about the corner cases to watch out for, it's easier to just say, isolate this, then work with it. You can, in this case. It will be the same. Yep. All right, so even if they look a little uglier than you're used to, they're just fine. Absolute value, you're saying a distance is more than this. A distance is less than this. You've probably heard this in terms of a tolerance. A tolerance, meaning, we got any diabetics in the room? No? All right. Type 1 runs in the family, and I'm clearly working on type 2. So give it a few years. Like my grandma, her type 1 didn't show up till she was in her 40s. And then I've got like 3 family members who all have it. So, but the reason I say that is blood sugar. You've all at least heard of blood sugar having too high a blood sugar or too low a blood sugar. Too high a blood sugar and too low a blood sugar means you might go into that catatonic state almost. Might even have seizures. Pretty goofy stuff happens. It's a tolerance. You need to be within a certain amount. An example that they give is this particular car, they want it to be between 51 and 53 inches tall. If it's any more or any less than that, it's outside of specifications. Prime example of that, has anyone ever put together one of those like furniture come in a box things? Like IKEA? Okay, you put in the Walmart mainstays, really, really terrible particle board furniture. Have you ever put that together and it's obvious that this bolt is just a fraction off and it won't go in? Or this peg won't fit there? There's manufacturing standards that say if you're going to make stuff, it needs to be within so much. They'll have a tolerance that says it has to be within this limit. If it's not, if there was just a little extra material in the mold and it's just like a hundredth of an inch off, it's not going to fit where it needs to be. It's called precision in manufacturing. If I have the two things that are upper and lower boundaries, I want you to think about that in terms of absolute value and inequalities. If I want something to be between those two, think about that in terms of a graph, right? At 51 and 53, in between them, the middle of it is 52. 52 is where I want it to be. How far away from 52 was I allowed to be? 1. Think about that in terms of the definition of absolute value. I want the distance to be less than or equal to 1 inch. I want to be no more than an inch away from 52. I want the distance from the thing to 52 to be less than or equal to 1. Put that into a formula and you'll never have to think on these word problems again. I always write it as absolute value of x minus what you want it to be is less than or equal to your tolerance. I want the kid to be at 180 pounds to wrestle. They're allowed to be within 5. Okay? Like they can be 5 above, 5 below. That's actually not true. They always want you to be like 2 ounces below the top of the weight class, and that leads to really unhealthy behaviors, but please write that down. That's so much easier. Okay? They're going to say, blah, 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 blah. What absolute value inequality describes the heights of the model race car shown within the indicated tolerance? I don't have to reinvent the wheel anymore. Now I got a formula that tells me how to run this. Come down here and say, suppose the least allowable height was 52 inches. The desirable height was 52.5. So they want it to be 52.5. X minus 52.5. Less than or equal to. They said you can go down to 52. So what's the tolerance? 1/2. And because they use decimals, we can use decimal. Who here is in debate? Precedent. Right? If you introduce this topic, this information, or this argument, I may now attack that as part of my presentation. You brought it up. I'm just using it against you. They started with decimals. I'm allowed to use decimals. Okay? So, it's all stuff that I had hoped we would get through yesterday. If you could please turn, let's ping pong around. Let's do, let's do some cooking and let's do some ugly decimals. I want you to try those two. Hmm? Yes. Someone could argue that both of those numbers are the meaning of life.
Zero, 7.
So I think it's mine.
I want it to be in the middle of those two numbers. Yeah.
Sweet. Let me go look back at the earlier one. So I was trying to find.
If you want to, with that x minus what you want it to be, also it's what you want it to be or the middle of your two limits. Okay?
Right?
The middle of your two outer boundaries is where you want it to be, right smack in the middle.
So the green or
Well, what is halfway in between those two?
that would be, well, it can't.
If you got to go old school and add them up, divide by 2, find the median.
Is that what I have to do?
Yeah.
For real?
You want to find out what's smack in the middle of those two.
So if I take that, would I just do that version or?
Add it to this,
Oh, yes.
divide by 2.
This is super helpful. Great teacher.
Okay, so we are x minus, this is what's in the middle. This is where I want it to be.
So we want
Did-
0.1782.
Oh, no. Okay.
Did I do a bad?
Order of operations, this just divided before it added.
Ooh.
So I can
I think that I don't know.
insert a parenthesis,
No, think about it. Okay, let's sit.
insert a parenthesis. There we go.
Cool.
So that's where I want it to be. 1185? 885. And how far away from that was I allowed to be? How far from here to here?
So I just say the distance in between.
Yeah, subtract them. Find out how far off you were allowed to be.
Thank you for your help.
Yes, sir. That's what I want. I want you asking. All right, let's go back to geometry. Y'all remember midpoints?
Yep.
If I want to know what is halfway in between the lower and upper boundaries, add them up, divide by 2. Yo ho. Well, if the middle is here, how far away from the middle were you allowed to go? Either maximum minus midline or midline minus minimum.
Why would you want to make
Okay.
I'm not saying.
I say it's broken, but it's not broken. I'm just doing something wrong. I can't get it out of scientific notation. And I tried the mode and everything. I tried switching it to normal and scientific.
Why are you multiplying them?
I'm plussing. I'm adding.
That looks like a multiply to me there, Haas. But once they do go to scientific notation, that's stuck there. Yeah. You just have to be smarter than the calculator and know what it means.
Scientific, whatever it's called, notation, but it just adds 4 zeros.
Right? So 0.00015. Okay, maybe we still got a little too much of that summer rust up in the gears. Okay, to find out what is in the middle of these two, what is halfway in between them, I will take 0.1187 plus 0.1190. What's going to happen if I say divide by 2 right now? Order of operations, it's going to divide this and then add. That's not what I'm looking for. So, couple ways. Option 1, go old school. Just hit equals and then divide by 2. Okay, that's one way. Option 2 is to use parentheses. 0.1187 plus 0.1190. And then divide by 2. Option 3, if you have a right view calculator, you set up a fraction and then put it over 2. 0.1187 plus 0.1190 over 2. Okay, so regardless, I now know where the middle is. If I know where it's supposed to be to find out how far away from that I'm allowed to be, I can take the maximum and subtract whatever that was, and we get scientific notation. Good thing we know how scientific notation works because we, passed physical science and Algebra 1. Negative exponent times 10 to the negative 4th. What does it mean?
That way. Move it.
Move the decimal that way 4 places. 1, 2, 3, 4. And what do I do with the intervening space? Zeros. So, D minus 0.11885 less than or equal to, I am allowed to be 0.00015 away from it. Okay, part 2. Use a thermometer. Varies +5 -5 from the setting. The setting is 350. It is set to, so I want it at 350. It is allowed to be 5 above or below it, so my tolerance is 5. If I want that as a range, a compound inequality of values, well, it's allowed to be, you know what? What if I actually solved it? Y'all know just common sense what it's going to be. But do you understand that this is x minus 350 less than or equal to 5, add 350? And dark side. Do you see why now we flip that inequality? When I add 350, I want it to be above 345, but below 355. And if you then wrote in between the two, okay? I didn't finish reading the problem. I don't know if it was asking for the absolute value or the inequality. I don't remember. Okay, one of those two. Tell me again, who had Algebra 1 first semester last year? So first semester fall 20. Who had Algebra 1 spring 20? Or would have been all year? Okay. It depends whether we're at sophomore or junior or senior. So, all right. So we're looking at, it's been a minimum year for most of you, 1.5 to 2.5 since you've done this stuff. Damn, man. Well, that ain't good. Flip it. I know we're not going to get all the way through 2-3 like I had hoped. Normally 1-6 is a single day. It just means we got some rust, we got some gaps. That's all it means. It's nothing on you. It means the world imploded and we got some gaps. Okay? Direct variation. Variation means to change. Direct. No detours, no extra, straight to answer. So direct variation altogether, anything that can be written as y equals x times k. If I want to know my output, it is going to be a constant of variation times my input. For example, there are twice as many girls as guys on the dance floor at homecoming. If I know how many guys there are, double it, I know how many of the ladies there are. Okay? And that's because guys got this idea that they're too cool to be out there. It's more because they're socially awkward and they're not comfortable in their own bodies. Very call me out. I'm the same way. Dancing makes me cringe, even watching other people do it. So, I should be able to take a constant, it's called the constant of variation. I find it by, if I want to know what k is, I just divide both sides by x. That's where this comes from. The constant of variation. In fact, you might want to write that part. You're just rearranging this. The constant of variation is going to be your output divided by your input. Your output divided by your input, y divided by x. That tells you what the rate is. Case in point, you get your paycheck back. You never bothered to actually talk to the boss. You were just happy to get a job. You get your paycheck back, and it says $320. And you're like, I don't even know how much I'm getting paid. Like, that's just the total amount. And then you look at how many hours did I work? I worked 20 hours. Output, how much I earned, divided by input, how many hours. $320 divided by 20 hours. How much you getting paid? 16 bucks an hour. Yeah, it is. I had this discussion with my my Algebra 1 yesterday. Y'all, around here, like locally, do not go work anywhere for anything less than 10 in town. Like, don't. If they are taking advantage of you. There are so many places right now that are hiring at 10 to 15. Do not take anything under 10 anywhere in town. Those places deserve to go out of business, just like KFC. Okay? Just saying, you are worth more than 10 bucks an hour. Okay? Yeah, it was. I like KFC. But if you're going to pay your employees crap, you deserve to not be open. Okay? So, all right, I opened that can of worms. We're talking about like money and teenagers like money. So, come on back. Okay, direct variation says, in that case, y equals 16x. That would be an example of direct variation. It's not, I'm paid this much per hour minus the $100 per check that my folks say I have to put into savings. There's that extra step. No. Direct variation. I go directly to answer. I just multiply by a thing and I'm there. Okay? So that's what direct variation is. I should be able to just straight up multiply and I know what I got. So they ask us, how do I know if I'm even varying directly or not? I should be able to take y, output, divided by x, input, and it's always the same constant of variation. You should be able to take your paycheck divided by hours worked on any given paycheck, and it always comes out the same. Okay, but those are all percentages. So it's still a percentage of the wage. So if I take 2 divided by 1, if I take 6 divided by 3, if I take 8 divided by 4, no matter what, it was always 2. So I know that this, yes, is direct variation. Not only is it direct variation, by doing all that dividing, I just found my constant of variation. I now know k is 2. So I can write my equation. Y is 2x. Fairly straightforward. Okay. I take 4 and I divide by 1. Output divided by input. I take 8 divided by 2. Output divided by input. I take output divided by input. Uh-oh. Not quite.
Oh. Wait. H should be a 4.
Oh, yeah, I should.
Brownie point.
Let's go.
Said, I want you to. I want you to. I will gladly give up trays of brownies if it means you're paying attention. The record. This is year 14 for me. The record. I had a Algebra 2 class get 3 trays of brownies off me.
Was that a year-long class?
That was over the course of the semester. They barely got it. They got it in review for finals.
I think we get a brownie point for you not telling us about brownie points.
That's not a mathematical error. That's procedural.
Wait.
So.
Is it like this works where like it gets bigger every time?
Yes.
So like couldn't go in 30.
I said they all stole it from me.
So it starts at 10? Oh.
We started at 25. Yo, there's 20 of you in here and one of me.
I was one. You only
It's like 5, 10.
Yeah, and I told her that she probably got just wrecked at the beginning of the year, didn't she?
Spartan time is
Actually,
like
no.
10 minutes we were quiet.
Yeah. Okay. Also, everyone knows that angry little leprechaun that lives on your shoulder that tells you you're screwing up, you suck, you can't do anything right. See, look, you did it again. And your whole world just spirals out of control the more you do things wrong until eventually you just accidentally knock over your water bottle and then you sit there and cry. Because of nothing. Okay? The angry leprechaun has told me over the years that you have a cap of 3 a day. Because if I go past that, I'm just going to keep screwing up and screwing up and screwing up. But if I stop it, and if I say, look, no more brownie points, if I screw up, I screw up. I'm just not in the right headspace. It actually helps me reset, and then I do better. Okay?
So we get 3 a day?
If you catch them. So, you got your first blood. Congratulations. Take a look at this. I've got 4, 4, and not 4. So, I'll say it is not direct variation. Okay? No. So both of these I would like you to tell me yes or no. Are they? If they are, tell me what the constant of variation is and what's the equation.
So, yes.
I just remembered today's a maroon day. Means I don't have freshmen next hour. I don't like my last block on a white day being a room full of 28 freshmen. Your pain amuses me. Okay, first one, yes or no? What is K? Lies. Second one. No. There is indeed a pattern to it. Okay? There is a pattern to it. It is a polynomial, but it is not direct variation. I can't just take x times something and get here, x times something and get here. They're not all going to be the same. If you don't believe me, 5 halves, well, that's 2.5. 7 thirds is 2.14-ish. 13 over 6, 2.18-ish. Okay, they're not the same. So if they're not the same, then it's not direct variation. Okay?
I just did. It was like a point off.
You just start memorizing what a seventh and a sixth and an eighth and are after so long. Identifying from the equation. The only way that this is going to be a direct variation is if I can write it in direct variation form. Can I write it as y equals number x? If I can, it's direct. If I can't, it's not. So in this case, if I just divide both sides by 3, it's direct variation because it's now y equals k times x, constant times x. So my direct variation constant is 7 thirds. Next one. Now, it divides, it gives me pretty numbers, but is it y equals k times x and nothing else? No, there's that additional step. I didn't go directly. You know, it's not like go directly to jail. They also said, by the way, you pass my property and I make the rules, so you're going to have to pay me $100 anyway. Okay? Home rules suck. So, that is not direct variation. So, the two below that, same thing. Can you rewrite it in that form? If it is, tell me what k is. Tell me what the constant of variation is. If you can't, then it's not direct variation. Can you write this as y equals coefficient x? Argue it out. What does it mean?
Did you get that?
Yeah.
I thought, yeah.
There you go.
Is that right?
Yeah, that's what I got.
I like it.
You are correct.
Yeah, I was thinking about that. You just make X, right? And you just make Y. I don't think that's what you're doing. They added together and equals numbers.
Okay, you're thinking of what we call compatible numbers. We'll talk about those when we review systems. You're doing a related thing, yes. Only because there was a 0 on that side. If there was any other non-zero number, this wouldn't have worked. But because it was a 0, k is negative 5 thirds. Over here, we ran into this when we were first doing the combined like term stuff, like lesson number uno. You remember? 1/9 x. Right? There's a little invisible 1 in front of that x. Okay. Get used to writing them both ways. You're going to see them both all semester long. So in this case, k is 1/9. Y equals 1/9 k. That would be like teacher pay after deductions. Y'all, family insurance is trash for this district. $1,500 a month just to make sure that if I end up in a hospital, they don't get bankrupted. Like, y'all, insurance, our whole healthcare system is just garbage. Anyway, fairly easy so far. Okay. All right, using a proportion to solve direct variation. See, here's why it works. If y equals k times x, we said we could divide both sides by x, and we would get k is y over x. Right? Like just divide both sides, that's k. And we said every time I take y divided by x, it's always going to be k. Remember, it was always 2, or it was always -7. So that means if this is the first y and the first x, the second y and the second x should still be the same thing, right? When I divide them. Y'all remember that a subscript isn't an exponent? A superscript, a number written above, is an exponent. It's a mathematical operator. A subscript just tells you this one, the first y, the second y. That's all it means. It's just a label on it. We got a lot of juniors on it. What is your problem, you goober? No, balanced and crap on your nose like a dog.
Sorry.
I almost wish I had like a squirt bottle and bad. Okay. So we should be able to. Hey, do y'all remember the transition property? Y'all remember the transition property from geometry? If A equals B, but B equals C, cut out the middleman, A equals C. That means I can set these up as just ratios. When they say it varies directly, I can take the first y with the first x and set it equal to the second y with the second x. I said x, but I meant 21. Okay? First y, first x. Second y, second x. Or maybe, in terms of high school relationships, the first x find y, the second x find out y.
9 times 21.
Maybe.
Say that one more time.
We'll tell you when you're older. So, how do I get y by itself? Okay. The way that I always learned it, I've told kids over the years, make the Jesus fish. What? And they say, who? What? What? Alpha? You multiply the two that line up, divide by the one that doesn't. Because aren't you going to take 9 times 21 and have -15y? So what will you have to do next? Divide. You multiply the two that line up, you will end up dividing by the one that didn't. So if y is 9 by 21 over negative 15, so I can do the mental math part of it. This is how I run things. In my head, I do it this way. Well, no. I'm thinking compatible numbers. That's next time. So 63 fifths.
12.6.
Okay. Ew.
So we're supposed to keep it in fractions.
They're both right because it's a terminating decimal. Okay. They are both correct because that was a terminating decimal. So, because direct variation always has the same constant, that allows you to set things equal to each other. Y over x equals the other y over the other x. You're always able to compare. Yeah.
Here, because of this, we can find k and then do it like this.
You can do that too.
I don't find the same results as you. I find.
Okay, so you said k is, oh, because k is y over x. That's why.
I didn't write it down.
Oh.
But when you had the, like, you did 9 and you made it 3 and then the bottom.
Oh, I was just cross-reducing. You don't have to do it that way. Just say y over x is, I don't know why, over x. Multiply these two. No, what's that? Man, if only you had a piece of technology right next to you that did that for you. Come on now. Okay, so you got 189 is negative 15y. So you'll divide by the negative 15. And this is why I said you multiply the two that line up and divide by the one that doesn't.
No, it was just when you had them written down, it was 3 and 5.
Oh, because I started cross-canceling, and you don't have to do that. No, just set it up like that, and you're good. I see. What are you?
Yo, where are you going?
Oh, we're still.
Yeah, dude.
We still have like 10 minutes.
Oh, we're back.
No, this is me processing emotion and trying not to throw something. Okay. So, multiply the two that line up, divide by the one that doesn't. There's also something I actually wrote. I wrote a thesis on it. There's something called a proportional reasoning. Proportional reasoning. How many of you didn't have to do anything else with it? You just saw, well, it's 5 times greater, so take that times 5.
I did that to double check.
Okay. That's called proportional reasoning. That's recognizing a proportion, which is what direct variation is, and being able to apply it on the fly. Some people can do it. Some people can't. No big deal. Cross multiply and divide. But either way, it is 60. Sounds like we're good. Hey. Well, y'all were pretty loud. We wasted a little bit of time, so sounds like ding ding. You're going to put these two on your own now.
Which one? Okay.
Problem 4, finish it off.
Right now? Start.
You're turning in your notes tomorrow.
Okay. We got some more time to take.